Example 4 is different looking than what we've done, right? It looks similar to stuff we have done even recently. Even on our last test, we had a problem that looked kind of like this. It was something like p to the second, y to the 0 to the negative third, x squared y to the second over p to the fourth, x squared y, something like that, right? I don't remember the exact problem. It was something along those lines. Laws of exponents were being used. We had to deal with the powers first, and then we had to move the negative powers and throw out the zero powers and stuff like that. What's different between this and that?
Plus sign.
There's a plus sign. Okay. There's also some parentheses, which there might be parentheses in those occasionally, but all this stuff on top is being multiplied, all the stuff on the bottom is being multiplied, all the stuff on top and bottom being divided by each other. This plus sign makes this a different kind of problem. All right? That's the bad news. The good news is you guys just agreed that what we're doing right now is pretty straightforward, right? Those last 3 examples pretty straightforward. Watch this. I'm going to keep the plus sign right where it's at. And what I want to do when I start seeing negative powers embedded in a problem involving pluses and minuses in a fraction is I want to leave each object where it's at and fix the negative power issue in that location. So what I'm saying is a to the negative 1x is on the top left part of this fraction, right? Mm-hmm. I want a to the negative 1x to stay there, but I don't want a negative power. So I'm going to make that x over a. Okay? You create the fraction in its location. Do not move the a to the bottom of the whole big fraction. Just create a fractional term within the fraction. The same thing here. I got b to the negative 1y. I want to put that up here. Y is a positive power, b is a negative power. So y over b is the same as b to the negative 1y. And then on the bottom I've got x to the negative first power, which is 1 over x to the first power on the bottom. Create fractions in their locations when you get pluses and minuses in these situations. Again, if it's all multiplication, it's what we've been doing forever, it seems like. Once you put a plus or minus there, it makes it this kind of a problem. And once you transform it to what it's supposed to look like, what does it look like?
Like both.
The last 3 problems we just did, right?
But there's no common denominator.
Well, we'll have to worry about a common denominator now, right? So let's take a look at this. So I got fraction 1, I got fraction 2, and I got fraction 3. I got 3 terms. Within this complex fraction, they're all fractions. They all matter with the common denominator. Least common denominator of a, b, and x is abx. All right? They're all different, so you just multiply them together. So times abx, times abx, and times abx. The abx represents a numerator object being multiplied by each fraction. So for the green multiplication here, this a on bottom, this a on top cancel. What's left is bxx, which is also known as bx squared. Plus.
Y.
And then the red one, this b on the bottom and this b on top cancel, leaving me with axy or yax. Take your pick. I like alphabetical. I'm going to go with axy. And on the bottom, this x on the bottom and this x on top cancel, leaving me with 1 times ab. And just like that, it's fixed. So when you start seeing pluses and minuses in these problems with negative powers, it's just one of these fractions over fractions problem in disguise. Write it in correct form and then fix it the same way we did the rest of it.